Side of the working backwards in composite figures. This is the side focused on composite figures, meaning a combination of more than one shape. So, if we need to find the area of the shaded region, that means we need to either treat each of these problems as part of a whole figure or a combination of several smaller figures. So for example, in this first one option is to think of this as one big square. And so if this is 3 centimeters and this is 3 centimeters and this is 3 centimeters, the whole length is 9. Because these are marked congruent, this is 3 centimeters, the height is 3 centimeters, the height is 3 centimeters. So tracing those across, the height is 9. And so we could find the area of the whole square and then take away the area of the little part, the unshaded section. The other approach is to divide what's shaded into shapes that we do know how to find the area for. And so in this case, we could extend this down and this one down, and we could have 3 rectangles. Or we could extend these across also, and we could find the area of each one of these squares and add all of those together. And that's probably the method that I prefer, but whichever one you see first that makes the most sense to you, feel free to just go ahead and use that. There's nothing that says that one method is better than another. So, if each of these little squares is 3 by 3, the area of one of those squares is 9. And then I see that there's 1, 2, 3, 4, 5, 6 of these little squares that are all 3 by 3. And so I can take 6 times 9, the area of each one, and get 54, and I see the label is centimeters, so 54 centimeters squared. The next one down. So this one, we're just interested in the shaded region. So we have this big rectangle, but there's a smaller section, in this case a square, 4 inches by 4 inches, that's subtracted out of it, that's taken away. We don't know exactly where this is located, so we could make up dimensions to say, you know, maybe this is right in the middle, and we could do this 8 by 4. And do the same thing for a rectangle on the other end and figure out these dimensions. Or you could move this, pretend that this square is in the corner and subtract it out from the whole rectangle. But any way that, well, but even that approach is then finding the area of the whole thing, which is a rectangle that is 8 by 12. So the area of the whole thing is 8 times 12. Which is 96, and then I want to take away, because the whole thing is 96, but not this unshaded region. So I want to subtract the unshaded region. So that's a square that's 4 by 4, in other words 16. And so if I take 96 and subtract 16, I get 80, and the label is inches squared. Study the next one for a moment. Pause the video if you need to. There are at least 3 different ways that I see to look at that. One approach, do you see one big rectangle that you can subtract a triangle from? Or do you see a rectangle at the right side and a triangle and another triangle? Or do you see a trapezoid connected to another trapezoid? And that's actually the one that I saw first, was the two trapezoids. And so that's the one I'm going to show the calculation for. But again, any of those other methods should lead you to the same answer. Will lead you to the same answer. So this top trapezoid, the two bases, the two sides that are parallel, are 3 meters and 7 meters. So I add the two bases together, and the height of that trapezoid is 2 meters. And then we have the second trapezoid on the bottom, and so base 1 plus base 2, still the same base lengths, 3 plus 7, but the height of this one is 3 meters. So calculate the first trapezoid. 10, half of 10 is 5, 5 times 2 is 10. The second trapezoid, 10, half of 10 is 5, 5 times 3 is 15. 10 plus 15 is 25, the unit is meters squared. The last one on the left column, how do you see this one? What kind of diagram do you see? I see a parallelogram plus a triangle. That would be one approach. If I look at the whole shape, well, these two sides are parallel, so it's a trapezoid. The whole thing is a trapezoid. Now, because I see this as a parallelogram, I know that the opposite sides of a parallelogram are congruent. So if this side is 15, this part is 15 also. So that means the whole base, 15 plus 20, is 35. So, using the area of a trapezoid formula, 1/2, one of the bases is 15, the other base is 35. The height of the trapezoid, the distance between those two, is 21. This arrow comes around and is pointing at the dashed line. So the height is 21. 15 plus 35 is 50. Half of 50 is 25. 25 times 21, type that in a calculator, 525. And the label is centimeters. So, try to use some of those techniques as you find the area of the shapes on the right hand side, and in any problem where you're needing to find a composite figure. Good luck.